Welcome to Friday House. I'm your host, James, and I appreciate you spending some of your time with us today. Time. We live in a world with countless stories about time travel and time manipulation, but we often overlook a fascinating scenario. Instead of traveling through time, what if time itself were to stop completely? Yeah, movies, books, and TV shows have depicted frozen moments in time, but what if they're all wrong? What if you truly witness if time were to come to a standstill? Let's take a deeper look and explore the physics and implications of a universe where time stops. When we hear the word time, we often associate it with the rhythms of our daily lives. The ticking of the clock leads us from one moment to the next. As creatures of habit, we've synchronized our actions to specific times. Waking up in the morning, eating 2 to 3 times a day, working a particular number of hours, and even specific times for worship and leisure. While we use units of time in seconds, minutes, hours, and even larger units, in months and years, these are based on the rotation of the planet we live on in relation to our sun. This is only to help us keep track of how much time's passed. In reality, time is simply a part of the universe itself and is not really broken down into any smaller parts, unless you count Planck time. For us in the heavenly bodies, time just flows, and everything flows with it. It's us humans who have to break it apart into smaller pieces to create a schedule for our daily rhythms. But imagine if all those rhythms, all those moments, simply ceased to move forward. What if time, the conductor of our lives, come to a halt? In this frozen reality, a world where time stops, the experiences we take for granted would drastically change. Sadly, it would be a reality devoid of experience itself. At first glance, the world would be plunged into complete darkness, as light itself relies on the passage of time, just like any other particle or wave. You see, our ability to perceive the world around us relies on photons. These photons of light bounce off objects and then reach our eyes. But without time to orchestrate these moments, photons would remain frozen in place. Our world, once vibrant with color and detail, would be swallowed by an all-encompassing darkness. But let's entertain the idea that we're equipped with a hypothetical time suit, allowing us to move and breathe in this timeless void. Could we then forge ahead, collecting photons as we move, and thus regain our sight? Unfortunately, even this scenario is bound by the laws of physics. Light, with its staggering velocity of around 299,792,458 meters per second, or 186,000 miles per hour, is a marvel. At the speed of light, the amount of mass accumulated becomes insurmountable, needing more energy than the entirety of the known universe can provide. Consequently, the very idea of achieving this velocity remains an impossible pursuit. Our endeavors to see would inevitably prove futile within the clutches of a halted time. And if that didn't already boggle your mind, brace yourself for this. Enter Einstein's theory of relativity, a cornerstone of modern physics. It tells us that the faster you travel, the slower your personal clock ticks. Astonishingly, if you could somehow reach the ultimate cosmic speed limit, the speed of light, your clock would halt altogether, leaving you in the same situation that you started with when time stopped in the first place. So in a way, the universe's ultimate speed limit isn't merely a barrier which restricts our ability to traverse vast cosmic distances quickly. It's also a threshold beyond which time itself loses its conventional meaning. This concept is profound, challenging our deepest intuitions about the nature of reality and emphasizing that the frontiers of our understanding extend as extensively as the cosmos itself. However, this notation leads us to another intriguing question. As Einstein posted, time and space are intrinsically woven together, forming what we know as spacetime. Imagine space-time as a fabric, and mass and energy as weights placed on this fabric. The heavier the weight, the more it bends and warps the fabric. This represents the gravity well around massive objects like planets, stars, and black holes. We've observed this interconnectedness through experiments where time dilation occurs near massive objects. When an observer enters into this gravity well, time slows down. The curvature of space-time around them causes time to flow more slowly. Imagine a clock ticking slower and slower as it gets closer to a massive object. So if time were to suddenly halt, it raises the question, would the fabric of space-time freeze in place as well? If the fabric of space-time froze, what would happen to gravity? Gravity, as we know it, is a result of mass curving the fabric of space-time. If time stopped and the fabric froze, does gravity itself stop working? While the scenario may remain firmly planted in the realm of speculation, it certainly makes us think. The intertwined nature of time, space, and gravity challenges our understanding of reality and ignites our curiosity. From the quantum mechanics of photons to the profound implications of Einstein's theories, we've glimpsed into the infinite mysteries that surround us. Remember, the concept of time stopping might remain within the realm of thought experiment, but it invites us to ponder the limitless boundaries of the cosmos and the uncharted territories of the mind. I encourage you to share your thoughts and ideas in the comments below. How do you envision a universe where time halts? What questions and insights does this scenario spark in your mind? If you found this video captivating and thought-provoking, don't forget to hit the like and subscribe for more experiences of physics, electronics, DIY, and more. As time waits for no one, I thank you for spending some of your time with us today.